Hello, my name is Max, this is Wilson, and we would like to explain in which way magnetic resonance imaging, or short MRI, in combination with a linear accelerator can be used to treat head tumors. We also show how the research of our group may increase the quality of these treatments in the future. Let's assume Wilson suffers from frequent headache, from nausea and double vision. The reason for those symptoms might be head tumor, and he gets an MRI examination in order to check this. So let's have a harmless look into his brain. The MRI scan visualizes tissue with different characteristics differently. So the healthy brain tissue, or the sweet pineapple, distinguishes from the sour lemon, which represents the tumor. For treatment, one can use a linear particle accelerator. You can think of the accelerator as a cannon, but whereas the cannonballs always impact at the surface, the particles impact inside of the tumor. To illustrate this, you can think of the ink as the particles and of the injection as the accelerator. The needle represents the depth at which the particles impact. So we take an overview image, locate the position of the tumor and apply the radiotherapy only to the tumor, unless Wilson moves and the particles impact inside the healthy tissue. In order to prevent healthy tissue to be harmed by an accelerator, the MRI needs to detect the head motion. But thereby we face some challenges. First, the raw data of the MRI are hard to interpret by the human eye. For example, the raw data of this image looks like this. Secondly, MRIs record the data sequentially, and this means we only see parts of the head. And third, all of this takes some time. We need to record the data, convert it, and also apply a motion detection algorithm. Some algorithms and we humans are especially good in interpreting the converted data, as our brain has learned to interpret the form and the shape of objects. We learned this as infants. We saw a ball and were told, this is a ball. Artificial intelligence works similar. We use those neural networks, which are similar structured to those of infants. We show them MR raw data and tell them the patient has moved like this. And we repeat this process until the neural network has learned to interpret the patterns in the raw data. With our approach, motion is detected directly on the raw data. Therefore, the detection is faster, and when motion occurs, less healthy tissue is damaged through the radiotherapy. Thank you for your interest.